Okay, I'm going to explain all the plastic pieces that I'm making for this little upgrade. First of all, the plate that covers the LED and the USB port has an opening for the USB port, but because this plate is so thick, you can see not much of the connector comes through, and it's not enough to really seat, definitely not seat properly. It barely makes contact with the connector inside. So what I did was I redesigned that with a pocket here to allow the connector to come through fully and seat properly with the mating USB connector. So that plate has been redesigned. I have a black one here just. The other side is where I want to put the switch to turn the power on and off. And it's going to have a little switch holder. So this is the little slide switch. And the way this works is there's a cavity here. This, by the way, was printed in this orientation, and this wafer thin panel printed just fine vertically with no support or anything. So the switch just slides in the top here and drops into a slot which allows it to be constrained, so it can't move in any direction except upwards. So to prevent it from moving upwards, on this side you can see there's a slot here where the lever had to slide down. So I put a faceplate which just covers the hole and allows the switch to be switched back and forth. So it covers up the hole, and it at the same time prevents the switch from sliding up back the way it came. So it's completely constrained now. Also, when it's in the module, it's directly under this printed circuit board, and the board itself will actually prevent the switch from coming up as well. So we don't need any fasteners. It just drops in place and everything fits just fine. So this bezel slides into the slots around the edge here. Also, we have standoffs. As you can see here, these internal standoffs for the circuit board were way too short, and there's actually a screw that goes through here into the standoff, and if these spacers aren't there, it will bend the board as you tighten the screw. So I've made these little standoffs which are actually protruding into the original bosses, and I'm just going to put pin fasteners in there, friction fasteners, to hold everything in place. And I'm sure that they're tight, so they're not going to come out or anything, instead of screws. So that's the plastics, and then I'll have to actually cut the positive wire here and run it through this switch. So that will complete the modifications, and I'll be back online here when I get it all soldered up. Just we have a visitor checking out the whole apparatus. Okay, this is just measuring the idle current, and you can see it's 258 microamps. So when I turn it on, it's 83 or 84 milliamps. and then it goes back down to 1/4 of a milliamp when it turns off. So that's the current that I'm going to get rid of with this switch, so I can turn off the current entirely. By turning off the switch. Okay, everything is more or less together and it's working perfectly. So we have the switch installed up here and the little dowel pins holding the card on. Nice and snug. Everything is really tight. There's a plate for the USB port and the LED, and it's in there nice and snug as well. Good friction fit on everything. And it's definitely a nice fit. There we go. So, of course, this color is just what I happen to have in the printer. And it certainly makes it easy to tell that it's been modified. So I'll screw that together and try a couple more tests. Okay, it's all together. Good as new. Actually, better than new. So here's a component that I purchased by mail order way back around the early 70s, back before the internet, and when we used to order things from the back of electronics magazines. This came from a surplus electronics store. I got a whole bag full of these. This is a nice blue color with a red stripe on the end. I guess I'm not sure if it'll focus on that, but it's a really cool looking device, and it's a pretty exotic part. So let's see what it actually is. Whoa, just dropped it in there. So it says it's a diode, of course, 2 leads, and it's got 356 millivolts forward voltage drop and a reverse current of 1.2 microamps. So this is a germanium diode, and like I said, it is decades old. Here's another part which I also bought mail order, a whole bag full of these things. There is no markings on this. It's just a rectangular block. So let's check out what it is. I actually know what it is, but there is no markings on it. It's taking a while to figure it out. So it says it's a capacitor, 29 microfarads. So a pretty large amount of capacitance. It says it's got a ESR of 1.1 ohms. And some V loss of 4.9%. So this is actually a tantalum capacitor in a funny package. It's not obviously polarized, except the leads are a different length. So it's really good for analyzing parts which don't have any kind of markings on them. Here's a big 3-terminal device. Let's just stick it in there and have a look at it. So this is an N MOSFET with a 2.4 ohm on resistance. So a really nice device. I like this thing a lot. It's cute, but I wouldn't use it every day. So I don't want it just sitting there draining the battery. So now I can turn it off, and it can sit there happily until I need it. these lithium batteries will last quite a long time without charging, as long as they're not being drained.